To understand static electricity, we first need to know a bit about the nature of matter. Matter is made up of atoms, which are made up of three types of smaller particles: electrons, protons, and neutrons. Electrons are negatively charged. Protons are positively charged. And neutrons are neutrally charged. Normally, the electrons, negatives, and the protons, positives, balance out. But electrons are very, very small. One of the smallest things in the universe. Because they are so tiny, rubbing or friction can give loosely bound electrons enough energy to leave their atoms and attach to others, moving across surfaces. When this happens, the first object, where the electrons were, is left with more protons than electrons and becomes positively charged. While the one with more electrons, where the electrons moved to, now accumulates a negative charge. This situation is called a charge imbalance, or net charge separation. So, when one of these newly charged bodies comes into contact with another material, in order to return to equilibrium or balance and become neutrally charged again, the electrons move to where they're most needed, and quick. They get off the negatively charged object and jump onto the positively charged one, in an attempt to restore to the neutral charge equilibrium or balance. And this quick movement of electrons, called static discharge, is what we usually call a static shock. This doesn't just happen with any object. Conductors, like metals or salt water, usually have more loosely bound outer electrons, but insulators, like plastics, rubber, and glass, have tightly bound electrons that won't readily jump to other atoms. Static buildup is most likely to occur when one of the materials involved is an insulator. In this case, we're going to be talking about a wool rug, which is an insulator. When you walk across a rug, electrons from your body will rub off onto it, while the rug's insulating wool will resist losing its own electrons. There is now a charge between your body and the rug. So when you reach the metal doorknob, zap! The metal doorknob's loosely bound electrons hop onto your hand to replace the electrons your body has lost. Now let's try this out with a simulation. In John Travoltage, we can use the motions of John Travolta's body to see how negatively charged electrons move. When he moves his feet across the carpet, back and forth, back and forth, back and forth, creating a rubbing or friction, we can see how the motion causes an exchange of electrons. Now there is a charge imbalance. Then, when he touches the doorknob, zap! We know this happens because the doorknob is made of metal, which is a good conductor, so electrons can move quickly and easily from surface to surface. So when he touches it, the electrons move up and through his fingertips. This creates a static shock. Let's try one more time. Again, his foot moves back and forth, back and forth, back and forth, back and forth, and you can see that it's causing his hand to be shocked when it comes into contact with the metal doorknob. Great! Now you understand what static electricity is and why it happens. Just a reminder, static shock is caused when two objects are trying to reach a balance due to an imbalance of electrons.